Hello, you're welcome to our channel Lookout How To. In today's video, we will be demonstrating how to use the validation rule for purposes of conducting data quality control. Recall in our previous videos, we discussed other types of attribute rules, which includes the immediate calculation rule and the batch calculation rules. We showcased how to auto-populate attributes of features based on relationship with other features. I would recommend you visit our channel to watch those videos, as this is a follow-up to those videos. So we will be using a case study. We want to validate the accuracy of point of interest based on set rules. The point of interest are point features that are supposed to be within local governments as captured in the attributes table. And so we are assuming that the local government boundary map is accurate, and we want to use it to validate the accuracy of the point of interest data. So the data requirement here is the POI, which is point of interest that will be validated, as well as local government polygon features, which will be used to validate the POIs. Now, in validation rule, rules will be set, and the system will be configured in order to flag errors that violate those rules. In this project, we are interested in the geometry of the point feature class, which is the point of interest. We are interested in whether or not the points have missing coordinates, or they are falling in wrong locations. For example, points that are supposed to be in Abuja Municipal Area Council are falling in Obiakpo local government in River State. The system will be able to flag it. And then some points may be falling even outside the Nigerian boundaries. So these are rules we will set using the ArcGIS expression, and then the system will be able to validate and expose those points that are having wrong geometries. We will also witness errors as a result of case mismatch, spelling mismatch, as well as leading and trailing spaces that will be flagged as if the data is incorrect. They are actually incorrect in terms of attributes accuracy, but in this case, since we are interested in the coordinates, we will use logic to refine the ArcGIS expression in order to go through all those common errors of spelling and case mismatch. And so let's go to the steps that we are expected to follow. First of all, if you don't have a geodatabase already, you create one, and then you import the local government boundary map, which is a polygon, and then you import the points of interest into the geodatabase and the local government polygon both into the geodatabase, and then both will have a common field expectedly. So the local government will have the local government name, and then the point of interest will also have the local government for which each of those point of interest is located. Then we will create the validation rule. First of all, we are supposed to configure to enable it to have a global ID, and then an editor tracker will also be enabled. And then the next step is to run the evaluation geoprocessing tool, and then it will produce error layers which will be added in the map, and then we will inspect the errors and check if if you are not satisfied. We'll keep refining until we are satisfied, and then we will do the summary of the reports, and then that's all. So you're welcome to the practical session. These are our features. We have the point of interest, which is the point features, and then the polygon feature, which is the local government boundary. So you can see these are the boundaries and these are the points. So what we want to achieve is to evaluate each of the point features to be sure that they are located in the actual local governments they are meant to be. So let's go straight to our attribute rule. We will we will create a global ID. So here we already have a global ID checked. So it means we have global ID in the attribute table. And then secondly, because we are conducting a validation attribute rule, we are also expected to enable editor tracker, which has been done. In attribute rule, it's compulsory for you to always create global ID. But for other rules, there are some of the rules that you are expected to also enable editor tracker, such as the validation rule. So to create the rule, we right click and then go to data design and then attribute rule. From the attribute rule, you have the three types of rules, which is calculation, constraint, and validation. We've discussed about the calculation earlier in our previous videos, where you have two types of calculation, which is batch calculation and immediate calculation. And we also, so we've discussed it too. Today we've jumped to validation. And to create a validation attribute rule, you just come to add rule, and from add rule, impute the relevant details. So we can call it a POI validation. And then we can just repeat it. And then we don't need any subtype. And then we also don't need to exclude from application evaluation. We want it evaluated at the application level. We don't want it to reference the geodatabase when during execution. And then error number, we can just give it an error number, and the error message, we can just give it invalid data. And then we can just severity, we can just put that. And then tags, we can just also say validation. Yeah, so these are the elementary configuration. And then the next is for us to go to the ArcGIS expression, which is the logic that will power the attribute rule. So let's comment on exactly what we are going to do here. So first thing we'll do here is to load the data. And the second, we will write a rule that flags empty coordinates. So empty coordinates we mean points that lack geometry. And then the next one, we'll write rule that flags sites that fall outside of Nigerian boundary. So write rule to flag. And the next and final rule is to check that the geometry of the point of interest and that of the local government are the same. So we are bringing the geometry of the point. So we say geometry $ feature will is referencing the active feature, and so let us give it a name. LGA, no, var POI. So that's the name. So after loading that, let's also load the LGA. So use a feature set function $ data store. So you're referencing the data store, which is the geodatabase, and the name of the LGA is LGA, comma, and we want an efficient code, so we are only interested in the LGA name, and it's called LGA. So let's test this, line 3. So here is actually data store. So let's test it now. Sorry. Yeah. So let's save it somewhere. But before saving it, let's do an intersect between the two of them to see the sites that are falling in each of those local governments. So I will use the intersect function to see this, comma this, and it's good. And we want to see the first. So what first means here is it has intersected, and in intersection I need it to pick the actual feature, because a feature, when intersected, it may come with a number of features that are intersected. So we just need the first. And so in doing that, we have picked, because in this case we'll get only one point that is intersecting with the polygon. So we can say intersect POILGA. So we give it that name and say var. Yeah. So we've done that. So let's write a rule that will flag an error where there is no geometry. To do that, we use if is empty. So we are saying if this point geometry is empty, when it's checked the geometry and it does not have coordinates, it should give me an error message. So it should return an error message. The error message should read point does not have geometry or coordinates, right? And this also, sorry, should be quoted, right? So let's check. Yeah, so it's fine. Now, the next thing we have to do is to write to flag whether it's outside of Nigeria boundary. And here, this is the intersect. So we'll check if this is within Nigerian boundary. So when it is empty, it means the point is not within any of the local governments. So we, like I said, we want to write a rule that flags the sites that fall outside of Nigeria. And so we will write the expression, the ArcGIS expression. And so we'll start from it's empty. We are trying to test if this is empty. If the intersection between the point of interest and the local government boundaries is empty, that means it's falling outside of it, there's no intersection, then it should return an error message. So, error message. So what's the error message we are going to flag? We are writing an error message. So we just say point false outside of Nigeria bound. Yeah. So the point false outside of Nigerian boundary. So let's check. Yeah, so the moment after the intersection and it's flagging 0, it will just give this error. Now the next thing we are going to do, so we want to write the rule that flags differences in the point of interest feature when compared to the local government. And in doing that, let us bring the name as it is captured in the point of interest, as well as the local government name as it is captured in the local government. But that also, we are taking a look at the actual intersection. So let us bring it in. So let's call it var string A. So we are calling it string A. So the string A is we want to use it to store the name of the local government that is of interest. So let's use a $ feature dot LGA name. On the attribute table, we name it LGA name. So let's check it. Yeah, so this will bring out the name of the LGA, the complete name. And then var string B, so we are referring to the intersect, but how it is named on the local government boundary map. And we already have the first intersect here, named intersect POI LGA. So we still use dot LGA. So let's see. Let's just use console to fish out the names. Yeah. So let's see the console. Osisioma Ngwa. That is what it's telling us. Let's test if string A is equal to string B. So it will tell us true if it is equal. Okay, so sorry. So console string A equals this. So let's check. Yeah, it's saying false. So this Osisioma Ngwa, I think it is spelled differently. Let's see how the two are spelled. Sorry, I need to put a space here. So this is Osisioma Ngwa, is capital letter, and this is this in proper capitalization. So it is flagging that they are not the same, but they are actually the same. They are actually the same. So in this very case, we will figure out with some logical string manipulation to go around it. So this is what we actually want. We want a situation where it will compare the two, and where it is not comparing exactly the same, it will flag. So let's we need to write a small function that will check and see that it's similar. So function is similar, and we need a string 1, str1, comma, str2. And what are we going to do with this function? We want to compare. We want to say if str1 equals to str2, then what should it do? Return true. So it should return true when they are. Else, it should return an error message. Else, return error message either very likely the point is falling outside the correct or intended LGA, or there is string wrong name, okay, or named LGA is named wrongly in the POI attribute. So this is the error message, although it's a long error message. So we have returned it. Let's check whether it's valid. Yeah, so it's valid. And then we will now call our function is similar, and we want to use the string A and string B. So st A, comma, strb. So it's been called. Say OK, and say OK. So that is done. And the next thing, we have to go to geoprocessing, and then we will run an evaluation rule. Yeah, we have it here. So we'll go to our geodatabase and reference. We are writing the evaluation to reference our geodatabase, and then we are conducting an evaluation rule and not calculation. And then we will run it. So we've got it right, and let's see if we can add the error layers. Usually I get this problem, so it will be grayed out until I will restart the project. So let me do that. So we'll right click it, and then we'll find the error layer here. See add error layer. So it's flagging almost all. Before now, we did not check the total number of sites. So let's take a look at the total number of sites. So we have 9,291. And now our error point errors is saying that 8,213, almost 1,000 sites only are clean. However, we earlier mentioned that there are situations where the geometry of the points are correct, but the rule will still flag as errors due to attribute errors such as spelling mismatch and case mismatch. So for example, let's take a look at this. So let's let's check what is wrong with this. Here, the name of the local government is Kogi, and it's a proper case. And let's see how it's written here. Here is Kogi, is a proper case. So this might be the reason. So we will have to write an accurate expression using some string manipulations to increase the accuracy. So we'll go back to our attribute rule. We'll come to design. So we will use trim. Trim will remove all forms of leading and trailing spaces. On this, on this STRA and STRB, so let's use trim to remove all leading spaces and trailing spaces, and we use proper to convert both field names for, both the names for the local government polygon as well as the point of interest points. So we still use trim. and proper. After which we will now test. So let's see. Yeah. We'll go back, save the attribute rule, and then we'll come this way, and then we'll run another evaluation. Let's quickly go back. And then we still pick our validation. And then we will run. So it's successful. Let's now go to the error layer. I will remove this error layer and add a new one. So let's see it. We can see that just visually looking at it, the number of errors, the errors are the red spots. So let's take a look at this area and see the kind of error associated with this. So this one, remember we have applied proper as well as leading and trailing spaces. Here the local government says Sabon Gari. So this has an iPhone in between. There is an iPhone in between, while on the point of interest there is no iPhone. So that's where it's pointing out. But there is something we can still do. Before then, let's take a look at the error, the point error layer, and see the number. We had 8,213 errors before now. Now we have 1,080 errors, which has reduced by about up to 7,000 have gone. And let us also take a look at the point of interest. There is a new field called validation status. On the validation status, this is the actual point. So it's let's sort. So all these are the ones that have errors. So let's see exactly what this is. So let's zoom to the point. So this one is saying it has error. So we can actually take a look at, this is Osisioma Ungwa, and this is saying Omoma. So they are two different local government. This is one of those we are very much interested. Because we have an iPhone in between, there is something we can do. We can just use the left or the right. We can just use the left string function to pick only the first 3 or 4. So data design. So let's go to our, yeah. So we are saying pick only the first 3 letters and compare. If they are the same, just assume they are the same. Okay, sorry, 3. For both the point of interest and the local government name. So let's see. Save it. After saving it, let us now go to and then run the error layer afresh. So let me remove it. Yeah, so it's done. So let us still add the error layer. Let's take a look at the number of errors left now. So we have 295. It has moved also from 1,080 to 295. There might be further string manipulation we can do to reduce it, but majorly, let's inspect a few of them and see whether because what we are focusing is the geometry of each of those points. So now this is the local government name is Emoha. So let's check it. Emmanuel. So this one is EMU. So this is one of those our string manipulation is unable to solve. This is EMU O, while the one of the points is EMOH. So they are spelled differently, but the geometry is correct. So these ones we may have to deal with them separately. Maybe we'll go further to reduce to first two letters, and we'll get a better result. Let's not forget it may compromise the accuracy. So let's go and reduce it by first two letters. So let's reduce it by first two letters. So left 2 and 2. So by this, I believe we will get a better result. So let's run it again. Let's run it again. Yeah, so it's done. Let's take a look at, let me remove this and add another point error layer. Let's see. I think you can hardly see any error there. So let's take a look at it. So it has moved from 295 to 254. Let's take a look at this. The okrika, we have seen only one. So let's see exactly what the problem is with this one. So this one is saying Port Harcourt local government and is falling in okrika local government. So this is obviously wrong. So this is what we want. At this point, inspect the kind of errors we have. So let's go to the error message column. So this is the error message column. So we can just create a summary. So let's go to the error message and count the number. Come here also, the error message. I'll add it. So let's take a look at the nature of the errors flagged. Yeah, so we have 3 categories. 90 of them, the point does not have coordinates. For 90 of them, 5 of them are falling outside of Nigerian boundaries, and the last one, it's very likely that the points is falling outside of the intended local government, or the local government name is wrongly imputed in the point of interest attribute. So this basically is what the evaluation rule can help us do. Imagine you have thousands of data sets and you want to evaluate the accuracy. So it will help you in your quality control task. So if this video is insightful or helps in any way, please don't forget to like it and share to others who might be interested. And also don't forget to subscribe to our channel and also follow us on LinkedIn, Emmanuel Avula. Thank you very much. Bye.